You're nothing posts in the book where you can find.
Have you heard of rock sharks?
Naturally, so evident.
There's a lot of stuff. Sharks are cool. Sharks do lots of cool stuff. Okay, so I wanted to talk about how to study for this class because I think we're having some folks are struggling, particularly with homework and things like that. So I'm going to jump into the different tools that you can use in ALEC. I'm not going to be able to cover every single tiny topic to do with chemistry. We meet 2 hours a week. This is technically a hybrid class, so on Fridays, you should be spending that time going through, working on your homework, diving into the content. There's just so much here. I can't hit every topic. So I focus mostly on the things that I know students are going to struggle with the most, the harder concepts. Now there's some concepts that pretty much are algebra based. So like this one, I think it's this one, maybe or maybe not, okay. So if I were to go through and I'm looking at this, you have lots of options to go through and you're like, I'm freaking out already. Well, you got a nice little side panel here. I made a little video with screenshots where all these things are. You can go, hey, you'll lose your current attempt, but guess what? You can keep trying until you get it right. You can keep trying until you get it right. This one, this is essentially your worked out example for you with the actual numbers that you started with. So this one has a full explanation with the numbers that they gave you, worked out step by step. First we do this, then we do this, all the way through. And if you're like, okay, well that's great, it worked it out all for me, but what if I want to be more involved in that? Well, I can try another. Go, okay, this is guided solution. All right, so I could go through using the same numbers, write the equation as a fraction. That's step one. So if you're more of, I got to go step by step with me involved rather than just reading it, this is what you can do. And then it won't let you go to the next one until you fill in these numbers. You're like, okay, well, maybe I don't know what I'm doing. Show me anyway. Okay. This is how I'm supposed to write it. Okay. Now I can go to the next step. If you're ready to try it again, you can return to the question. Try another. Like, maybe I don't want to do that. Maybe I want to see an example, but not lose my attempt. This is kind of similar to an explanation, but it's got different numbers, right? So you got this option. Sets it up similarly with each part listed with the answer, but it's different numbers. If you're like, well, I don't like that either, you can go to your book and it takes you right to the section that you need in the book. Uncertainty and measurement. I'm like, okay, so maybe I'm having a hard time with significant figures. I don't necessarily want to read the textbook. Well, you got PowerPoint notes that are listed within the course. Let me show you those. I'll just close that out. So if you look under here, where is it at? It's the glare. Okay, so I'm just gonna close that out. Go over here to Alex. Okay. Like, I don't really want to read that portion. Okay, fair enough. You can read a shortened version in the PowerPoint notes. And if you're like, well, I don't want to do that either, then you can go to this channel and watch a video about it from Tyler DeWitt. Textbooks, use his stuff. Significant figures. Oh, hey, look. Here's a whole playlist, and the videos are 5 minutes. Let me spend 5 minutes watching this video. You're like, well, I don't like the way he looks. He bothers me. Then you can go to Khan Academy. Say, hey, check this out. Okay, now we've got all of these. This is an entire year's worth, general chemistry 1 and 2, right here. Mixture of videos and reading stuff, right? All broken down in little snippets. Maybe you like that better. If you're like, you know what? I feel like I just need to work problems. Hey, look, STEM sheets. Pull that up. You're like, well, but what about significant figures? Well, then you just type it in the search bar. I probably spelled it wrong. Maybe, maybe not. Really? This is my day, isn't it? All right, so
Put S and it.
there we go. It populates for me. Significant figures. Enter. Look at this. Scroll past the ads. Significant figures worksheets. Same thing as the others, gives you the answers. So, what I'm trying to show you here is I wasn't kidding when I said 6 to 9 hours outside of class. This is like playing a musical instrument. We come to class, pick up the flute. This is a flute. Here are the buttons. This is how you put your hands on it. Then you got to go home and play it over and over and over again. Okay? This is a guitar. This is where you put your fingers. This is why I said none of us are going to be Prince good in chemistry. Okay? You got to go home and practice and practice and practice. But you have so many tools available to you in so many different ways. And if you're like, well, I need to just go back and see what Ms. Williams was talking about, hey, check this out. I'm live streaming right now. You should be able to go to my lecture channel, find General Chemistry 1, what we talked about in class. Speed it up fast, put on the closed captioning, get to wherever you missed. So you got everything that you could possibly need in all kinds of different ways, diversified to meet your individual need as a learner. I cannot come to your house and work with you one-on-one like that. But I'm here all day on Friday. I'm here during my office hours. Miss Steele, I have added her to our class. She's got all my old tests. She's got your homework printed out with the answers. She knows exactly how I teach and what I look for. So if you need one-on-one help and my office hours aren't available to you, she's here from 7 to 3, Monday through Thursday, and I think until noon on Fridays. I'm here all the time. So you got everything available to you. There's even a net tutor that you can go if you don't want to leave your house. Net Tutoring Center. So you can click on here and work one-on-one with a chemistry tutor from the comfort of your own home. So we have all of this available for you. Because I'm one person and I'm not available 24/7 because I gotta sleep. You know, I need my own self-care days, like on the weekends to recharge. So yeah, this is a part-time job, taking this class. So if it took you 4 hours to get through the homework, hey, I was expecting 6. So 6 hours to study per week, 6 to 9 hours, doing your homework, looking at those worked out problems, going through all that, that counts as studying. So when I asked you at the first day, what does studying look like to you? Doing your homework counts as studying. You're spending time practicing, thinking this way, right? So you gotta commit to it. I'm here to help you, but I can't spoon feed you chemistry. I wish I could. I wish I could download it into your brain, just hook you right up. Shh, I know Kung Fu now, along with chemistry. That'd be awesome, wouldn't it? But it doesn't work like that, unfortunately. So, any questions? Y'all see what I did? All for significant figures. Looking through. I didn't like this, so I went over here. Maybe you like that, maybe you don't. You got another option. Maybe you like that, maybe you don't. You got another option. Part of this class is finding out how you learn, because it's just going to get harder from here if you're a science major. I was not kidding when I said, think about how many valedictorians you see in college who are science majors. I cannot think of one at all over the course of the past 15 years. Not one. It's hard, okay? But it's doable. I had to take chemistry 2 in additional time because I did not understand I had to work 6 to 9 hours outside of class. I had to take organic 2 in additional time because I didn't understand that I had to work 6 to 9 hours a week outside of class. It took me messing up twice before I figured out, oh, I got to zero in, buckle down, and I also didn't like chemistry because I didn't understand it and I had a hard time with it and I was afraid of it. That I've learned, okay, I really want this biology degree. I'm gonna have to sit down, buckle down, and learn it. Ended up going to grad school for chemistry. My grad school GPA is phenomenal. It's almost perfect. My undergrad GPA is terrible because science major, right? Science major. That's just how it is. I have 4 degrees now. They ain't looking at my undergrad GPA. They're going, what are you doing as a professional? And I still get offers. Had one last week for another job. So I still get offers. So they're gonna look at what you're doing. They're gonna look at your work. So buckle down, jump into that and treat it like, okay, we gotta just do it. Like Nike, right? I got my Nikes on. You just gotta do it, man. You just gotta do it. And that's going to look different for every single one of you. But if you need help figuring out how you learn, come to my office. I'll help you. Let's come up with a plan, and if that don't work, let's make a new one. We don't want to keep doing the same thing if it's not working for you. So we're going to make a new one. All right? You're not alone, and you're not by yourself. Okay. Any questions? We doing all right? Okay. Yes.
It's like a lab, so, if we have a question about the lab, during the lab, if you will take questions or not.
It depends on what the question is. If it is, what are we doing? Then I'll be like, look at your procedure. You know? But if it's like, I need a clarification, I don't understand what this says, that's a different question, isn't it? Okay, no problem. Any other questions? Okay. All right, let's talk really quickly about significant figures. Y'all know why we even have significant figures?
Precision and accuracy.
Yeah, what does that mean?
To make like big numbers small.
Maybe.
Be more exact, like that's wrong.
More
Make the
Deal with human error. But we're hearing lots of things here. Basically, what significant figures has to do with is data integrity. That's not something people think about. It always made me mad that I had to learn about significant figures. I'm like, well, why then? Nobody ever told me why. So significant figures, we have this for data integrity. It has to do with the precision of your instrument. You cannot be more precise. You're as, well, let's say you're as precise as your weakest instrument. Only as good as your weakest instrument. How about that? You cannot use lots of decimal places to report a measurement for something if your instrument doesn't go that far out. Right? That's dishonest. So, on our scales out there in the lab, I think we can go to maybe 2 decimal places for grams. Some can go to 3. But if you're measuring something, let's say with precision and accuracy, if we take a measurement and it's 0.03, 029. So this is more expensive. So let's say we were using our more expensive scale, but it broke. More expensive scale broke because it goes out to more decimal places, right? If you can go out to more decimal places on an instrument, it's more precise. Because it can measure to smaller amounts, right? So let's say you're working in a lab and you're supposed to get the mass of a particular thing. And you're like, I'm going to use the fancy scale first, and then all of a sudden, smoke comes out of it. You're like, oh, what am I going to do? Well, you still have to report your measurements to your supervisor, right? So, how do I handle this? Well, what I do is I'm going to add all of these up. I took 4 measurements, and then I'm going to divide by 4. So, what is that? Ain't nobody gonna pull out a calculator to do this math?
0.19.
You got 0.19?
It's 2 5s and then.
Is that it?
Point one over.
0.029 plus,
That's wrong. And
okay. See, this is why.
then 0.1.
109, yep. This is why we always write stuff down. Now I'm gonna divide it by 4. And I got 0.02725. Do I take that to my supervisor? Is this being honest? He's gonna say, do you have a nicer scale that you're hiding from me? What's going on here? So what do? I report to the number where I have the least number of significant figures. So in this case, I'm just going to that decimal place. So I don't say that, I say it's 0.03. And if he's like, well, I want to see your data, you can show him or her and say, hey, look, here's my data. This makes sense. So we use significant figures to be honest in our data representation. We use significant figures to be honest in our data representation. That's why it's important. I hated trying to memorize all these freaking rules, but now that I know why, I could never go to somebody and say, well, this is how much it weighs. Well, that's not true. I could only, my nicest machine went to here, but it broke. So then I had to use these. So I have to report it that way. So let's look at what those rules are. I like to just pull up images sometimes. Huh, well, that's not it. Okay. There we go. Oh, look at that. There's a calculator for it. I'm just going to show you really simply. All right, let me open this in a new tab. Okay. Here we go. This is about which zeros matter. Because we know non-zero numbers count, right? Some of these zeros are placeholders, some of them matter. So, first I'm gonna put sig figs, significant figures, which zeros matter. Okay? Zeros in between numbers. In between non-zeros. We count those. Zeros at the end of a decimal, that matters. Not the ones in front of numbers after decimal. These are placeholders from other non-zero numbers, right? These are just placeholders. This one's part of the measurement, and this one lets me know how far out that measurement can go. This zero is part of the actual measurement because it's in between two non-zeros. This one lets me know that it goes out to this many decimal places. These I don't count because they're just placeholders. Okay? Now, if I had put a 5 right here in front of this, now it's part of the measurement. So if I have a non-zero number up in the front here, now it's part of the measurement. But just this by itself, is placeholders. That one counts. Those that trail at the end after numbers count. These in the front, unless there's a whole number right there, placeholders. And why? We've all just decided, scientific community decided, this is how we're going to be honest about our data, right? It's how we're going to be honest about our instruments. Make certain we don't report to too many decimal places, because we just, you know, that'd be a rookie move if you wrote down data that had all these zero, you know, yeah, you don't want to do that. That looks like you're intentionally misrepresenting how far out your instrument goes. So that helped me sort out in my head better why significant figures are important. Okay, how are y'all doing with this?
It be like, sometimes I be like, when we're out like guessing, because it's like, sometimes I ran this way, it'd be wrong. If I ran another way, it'd be right. I don't know, I can't explain.
So,
That would be like scientific notation, that would be a 5.
what do you mean?
Like on the homework, it was like, we were doing significant figures for like the lowest scientific notation. And it was like a number times 10 to the -5th power. Was that like,
So,
like, what would that be in scientific notation?
okay, so if we took this and converted that to scientific notation, I'm gonna go over here to this for you. So I'm just gonna write out that number. All scientific notation is are basically powers of 10. So this is 0, 0, 5, 0, 5, 0, 8, 3, 0. If I want to convert that to scientific notation, all scientific notation is the non-zero number, decimal point, and then everything that's after that times 10 to the decimal spaces it took. And you got positive or negative. So So I'm moving from left to right. I've moved 1, 2, 3 places. 5.0830 times 10 to the third. 1, 2, 3. Since I moved to the right, that's going to be a -3.
I guess we're not.
You wouldn't write the number like that,
You
though.
would
Oh,
say
you said it wrong.
Okay, so if it said how many significant figures?
Yeah, I guess that's what I'm asking. How many significant figures in the top?
So here we've got 1, 2, 3, 4, 5. 5 significant figures. 1, 2, 3, 4, 5 significant figures.
Right. Okay.
Yes.
So in some, let me think, it was like saying, 102.2 degrees to Celsius, and it was saying, and it would be like a whole number, like 36. And then whenever I would like check it, so that I have to write down significant figures, even though there was only 2. Because there's a whole number.
Okay, so I need more information.
So it's,
So is that question where it was like a period?
yeah, I wanted like a period after just
Okay,
two things.
so if it was 2 digits, they want you to report a period, kind of like that. I'm not gonna be that ticky. But if it says they want you to definitively show that there's 2 significant figures, some schools have thought you have to put a decimal point there to show that there's 2 significant figures there. I'm not gonna be like that.
My physics teacher did that with like 300, but not with non-zeros.
Right, so if they said, if the question said, I want you to write 300 as 3 significant figures, then you have to put a decimal point at the end. Because if there's no decimal point there,
Then it's 1 second.
then it's 1 significant figure. Because to me, if I don't have a decimal point, that's not a measurement. It could be rounded from 298, you know what I mean? That addition of that decimal point lets me know
It is exact.
that this is exact, it is a measurement. Did that help?
Yeah.
Okay. I'm not gonna be that mean on a test. Okay, 36 is 36 degrees, right? Your homework will always be harder than your exams, because that's where the work is put into for the learning. That's where the learning happens.
How would you round that one better?
This one,
Yeah.
if it was 5 significant figures, I wouldn't round that. But if I had this in a series of measurements, let me say another one was 0.00508. Let's say I had another measurement like that. Then what I would have to do is I couldn't report this as an answer. I could only go to 3 significant figures. So then that 3 is less than that 8, so that stays the same. Like that. So if you had a series of measurements, you have to pick which one has the least amount of significant figures, and you round to that amount. So like with this one over here, when we went through and took the average, which one of these has the least amount of significant figures? These do, right? So I have to round to just 1 significant figure. That's when I round. So then I would have to go, okay, I have to round this 2, and since this is a 7 next to it, it's 5 or greater, that one's gonna go up to 3. Okay? So if you're struggling with this, significant figures, Tyler DeWitt, great 5-minute videos to go through problem after problem, STEM sheets, endless worksheets with the answers. You can hit that. There's also those notes online, those PowerPoints, where you can find those. And that's how we do those rules. So that's just one of those things you gotta incorporate into your calculations for practice. Just keep going with it. Just keep going with it. Okay. Did that clarify stuff
Yeah.
a little bit? That might have to be one of those things you gotta marinate on for a little bit. Okay, let's talk about density. So density, I'm gonna erase this. Did y'all get this? Okay. In lab this week, we're doing density, we're doing measurements, so significant figures has to do a bit with those measurements. And when we're getting these measurements, we're also looking at density. So when you think of density, what words come to mind for you?
Mass, volume.
Mass and volume, what's that mean? What's
Width times height. Or volume.
length times width times height? Amount of space you take up and how much stuff is there, right? So density. How much stuff? Oh, sorry. Stuff taking up a certain amount of space. Wasn't that the definition of matter? Has to have mass and take up space.
Yeah.
So density is pretty much the definition of matter. Stuff that's taking up space. This is stuff taking up space. Right? Stuff taking up space. So, muscle building people. What did they say about fat versus muscle?
Fat weighs more.
Fat is less.
Muscle weight. Or muscle is more dense.
Yes,
Fat is less dense.
fat is less dense, but muscle is more dense. So you could have somebody that could be like weigh 300 pounds and have 30-inch waist, but they just walk around like this all day. Can't put the arms down because they got all that muscle mass, right? So we got a lot of stuff that's more compacted than spread out, right? So this is another tool that we have that I like to use. These resources, the PHET simulations. I use a lot of these because I like to see the interactions between variables. So I look at density. Here we go. Let's play around with density. I'm going to look at, we're going to play the mystery game. Okay. I'm going to do set 3. We're just going to do set 3. Okay, so in lab, we have unknown metals and all of that, and we're trying to see the relationship between stuff that's taking up space, right? So I've got a density table here. I want you guys to help me figure out what these blocks are. What are they made of? So I've got to get a volume measurement. That's where I'm going to do my displacement. And I got to get a mass measurement. So let's just start with this one. 3A. So what's its mass? Yep, so I've got box 3A. Don't know what it is. It's a mystery. Now, I could get my ruler and measure length times width times height, or I could just do displacement by water, right? So I'm starting out at 100 liters. Oh, look at that. Let me get it completely submerged. So what's the volume here? The difference is what? 3. But it floats in water. So my volume is 3. Is it less dense than water or more dense? Less dense than water. So how do I figure out the density of box A or box 3A now?
Goodbye.
Divide, right? What's the number? Do the math. Should be less than 1.
Should be wrong.
Because this is less than 3 and that's
Wait,
3.
is it human?
0.95.
It's point what?
No,
0.95. So where does it fit on here? All right, which one of you put a human in the box?
We don't vote. Oh,
Well, it would have to be individual. I float pretty great, man. I'll be all right. I'm less dense than water because, you know, my muscle mass ain't so great right now. All right, so we got, it's a human. I've never done this where human was the answer. That's funny. Yeah, 103.
You put it back in the water then?
This one,
Just like,
when it floats,
it's.
2.85, which means it would be 1. But that's not the case, so we gotta make certain.
Right, yeah.
Because if it was 1, it would just sink with the water. Okay, so let's see what 3B is. Y'all got your mass? I'm wondering, is it gonna sink or float?
It's a big one.
Do you think some, no, sink? It's like it's heavy, Miss Williams.
It's like, I'm saying something.
Let's see.
Yeah, that's-
Woo!
Might be mine.
Yeah, so it's 6. So 106 minus 100 is 6, right? So we had 6, was it 6 divided by 6?
Yeah.
So it's water. Here's a question for you. Does solid water float or sink?
Floats.
Why does it float?
Because it's ice.
The molecules actually lock into on the like fluid structure that it's.
Molecules require.
Yeah.
As they freeze. And the way that the method in which they freeze actually affects the structure of the crystals.
Yes.
One reminded
So we got 6 here for mass.
I did that, I didn't on that, but I some of the exercises more.
So it should be 6 divided by 6. 6 kilograms divided by 6 liters.
This is 106 liters.
Yeah, but see, when you take the difference,
Okay, never mind.
it's okay.
Okay.
So water, normally a solid version of a compound wouldn't necessarily float. But water, because of hydrogen bonding, as it freezes, it expands out. As oxygens are attracted to hydrogens on other water molecules, you end up with little air pockets. This is how we know what atmospheres were like millions of years ago. We can drill into polar ice caps. While we still have them, by the way. They're steadily melting, but you go far enough into ice on the polar ice caps, you can actually see what atmospheres are like, dated back a long time ago, because you can analyze what the air is within those little ice structures. Isn't it cool? That's some cool stuff. So water's interesting in that all that hydrogen bonding allows it to expand, making it less dense in its liquid form. All right, let's try this one. Oh, wow. Okay, that one's something. What's the volume on here? 3. See, y'all can subtract. That's awesome. Oh, wow. That's heavy. 23.40 kilograms. So this is box 3C. So the volume was 3 liters. Ooh, 23.40 kilograms. What's the identity of that substance?
Steel.
Steel. Y'all ever look at, I don't know if anybody goes to the gym or nothing, you notice some of those free weights are in kilograms? Maybe pay attention to what the kilograms are versus pounds.
I think they're on both, so I think sometimes they're on both. They're both in metric and imperial.
Yeah, sometimes both are on there. Let's do another one. Oh boy. I gotta push this down. So the volume is 5. Y'all get that? So I'm gonna take this over here. Two kilograms
That's what.
divided by 5. Anybody get something different?
So when it flows through the measuring and point portion form.
So we got 2 is the mass, 2 divided by 5. So that would be 0.4, right? So then I can ask, does this make sense? Does wood normally float? Okay. I'd expect steel to sink. Oh, wow. There we go. Okay. Yes.
When it floats and you get a displacement of its weight in kilograms, are you getting a buoyant force of 1?
I don't know. I'm not physics.
Okay.
Now, if you want to talk about quantum physics, man, I got you. Let's do this last one. 3E, 6 kilograms. Okay, so quantum floats, 6.32 in volume, 6 divided by 6.32. Are y'all getting ice?
Around you.
6 divided by 6.32. I'm still finishing my coffee.
I'm getting human.
0.949. Another human,
There's 2 humans?
maybe.
Are you supposed to submit?
Let's see. Oh, wait, you're right. 6.32. Yes, I got that.
I'm just saying, like, what if
Yes.
you didn't submerge the, like, what if?
Then I'm not getting an accurate volume because part of this is still hanging out the top, right?
So I think that's just point first. Because if you put a boat in the water, the displacement of the boat is just the actual.
Yeah, but we can measure the boat differently.
Right.
Yeah. Okay, so,
The water it displaces is it's just what it takes to keep it afloat.
right. So,
It's not the volume of the boat.
well,
It's the volume
still,
it takes to keep
if we want to get like the volume of the thing, we have to put it completely in.
something like that. 5 feet is.
Okay, so the next thing we're gonna look at, let's see. Let's talk about quantitative, qualitative, physical or chemical extensive renting. This is the last thing we're hitting, and then we'll start on chapter 2, which is all about the atom, starting with that. Okay. All right, so qualitative versus quantitative? What do you think of what word do you see when you see quantitative? So I see quantity. Quantity, which has to do with measurements. All right, qualitative. Let's do that one. What word jumps out from qualitative? Quality. Which has to do with observations. Right? So we can have quantitative aspects of an experiment, and we can also have qualitative aspects of an experiment. So quantitative would be actual measurements. Qualitative would be, is it green? Does it have a smell? Is there smoke coming out of it? That sort of thing. This would be like meters, grams, seconds, some kind of measurement associated with quantitative. Qualitative, that would be like color, shape, smell, consistency, yep. DNA looks like snot. That's how I know it's different from proteins. One time I was trying to extract proteins from a particular type of yeast cell, because that was what I did in industry, was genetically modified yeast to make proteins that we would use in order to test for antibodies for diseases. And I kept telling them, I'm getting a lot of snot out of this yeast. It's not protein. Well, we need to measure it and see what it is. Well, I'm going to tell you it's DNA. And so ran tests, it was DNA. Qualitative is how something looks observationally. Quantitative is actual measurement. Then you can measure how much DNA is in that sample. All right, let's talk about physical or chemical. What's the difference between physical change and chemical change?
Chemical substance.
Yep, you get a brand new substance. So what does that mean specifically? There you go, that's another way to say it. Physical, chemical. Rearranging atoms. Adding or removing atoms. So, rearranging, we got to be careful, because if we're talking about like a pure substance, you can rearrange atoms from a liquid state to a solid state to a gas state. But if we're rearranging to make a new substance, I'll put a little caveat there. Rearranging atoms to make a new substance, that's chemical. Physical, we look at mostly states of matter. We're shifting essentially same substance. There's no change. Whatever we do to it, we end up with the same substance of what we started with, right? The reason why I talk about rearranging atoms or adding or removing atoms, because when we start looking at chemical reactions, that's exactly what we're looking at. Rearranging them, combining them, removing them in order to make a new substance. That's what we're doing with that. Extensive or intensive, I'm just going to show you an image really quickly to show you the difference between the two, and then I'm going to leave it at that. And then I'll let you go. Extensive properties have to do with how much is there. Intensive does not matter how much is there. So extensive properties, mass, we're affecting mass, has to do with how much is there. So we're looking at measurements that deal with matter, right? How much stuff is there. Intensive, is it shiny? Doesn't matter how much is there. Boiling point, doesn't matter how much is there. Same boiling point every single time. Density, doesn't matter how much is there. Same density. That doesn't change. Okay, so that's all of chapter 1. We're going to talk about all things atom next class. Woo, no.